All right, let's just jump right in because today we're going to tackle a really wild idea. What if the basic logic that lets a large language model learn is actually the same logic that lets the universe build complexity? What if they're both, in a way, running on the same fundamental operating system? Our whole journey today starts with this one phrase, a supply chain of meaning. Kind of weird, right? But stick with me because it's the key to understanding how structure and information, and, yeah, ultimately meaning, gets from one place to another, whether that's across the cosmos or just across the layers of a computer chip. So, first up, two worlds, one skeleton. And what we're going to do here is look at two stories that seem completely different, how the universe creates structure, and how an AI creates intelligence. And you'll see they're built on the exact same framework. Okay, and check this out. This slide lays it all out perfectly. On one side, you've got the universe story. It starts with just random chaos, right? Blind variation. And on the other, you have the LLM story, which also starts with total randomness. They just call it blind initialization. Then both get shaped by outside forces. For the universe, it's selection pressures, survival of the fittest. For the AI, it's just being fed tons and tons of data. But here's the kicker, the part that connects them both. Both of them absolutely need some kind of channel, a conduit, to pass on whatever works, whatever survives. And the analogy just keeps going. I mean, look at the canvas each of these stories is painted on. The universe plays out across space and time. Well, for an LLM, its space is just its layers of neurons, and its time is the number of training cycles or iterations it goes through. It's a perfect one-to-one mapping. So here's the big takeaway from all this. The canvas might be different. We're talking atoms and galaxies versus code and parameters, but the logic, the fundamental rules of the game, they rhyme. It's the same pattern playing out in two totally different worlds. Okay, so this whole idea of survival, it makes sense in nature, right? We get that. But what in the world does it mean for a pattern to survive inside a computer? What does that even look like? Right, so inside an AI, survival isn't some big dramatic battle for its life. It's much quieter. It's really just about a useful pattern, like, say, the connection between the words king and queen, getting to stick around. The learning process reinforces it instead of wiping it away with the next update. It proves it's useful, so it gets to stay. It survives. You can almost picture the AI's training as its own little digital jungle. The environment it's trying to survive in, that's its main goal, called the loss function, which is basically just a score of how wrong it is. Its whole life is about getting that score as low as possible. And the predator? That's the error signal, always hunting for bad patterns to get rid of. And the weather? Well, that's just all the messy, unpredictable noise you find in the real-world data it's learning from. But wait, what about reproduction? I mean, an AI doesn't exactly have little baby AIs, right? So how does a good idea spread? Well, a useful pattern reproduces by spreading its influence. It nudges thousands, maybe millions of tiny connections in the network in just the right way. It's basically copying its own code, its DNA, into the very fabric of the whole system. So its good idea is felt everywhere. All right, so if these good ideas are spreading, something has to be carrying them, right? They don't just magically appear everywhere. And that brings us to the core of this whole thing, the courier and the message. We're talking about a delivery system deep inside the machine. So this is the million-dollar question. How does a successful pattern actually spread its influence? This isn't magic. There has to be a real nuts and bolts mechanism for transmitting that information through this massive web of connections. And here it is. The answer is gradients. Think of them as the carrier pigeons of the AI world. A gradient is just a tiny mathematical arrow that points in the direction of better. Each one is like a little note that says, hey, to be less wrong next time, tweak things this way. They are literally the couriers of learning. Now, this whole delivery network has a name, backpropagation, and you can basically think of it as a blame assignment courier system. After the AI makes a guess and gets it wrong, these gradient couriers travel backwards through the whole network, delivering little messages. They're saying, hey, you, neuron number 23 million, you kind of messed up. Adjust yourself a little bit this way. It's all about figuring out who to blame for a mistake. So it's this really elegant two-way street. First, there's the forward pass. That's just information flowing from your question to the AI's answer. Simple enough. But then comes the magic, the backward pass. That's when our couriers, the gradients, carry that message of responsibility, of blame, all the way from the final error back through every single layer, teaching the whole system as they go. And you have to understand, this is everything. Without this Courier system, learning would be totally impossible. The AI could spit out random guesses forever, but it would never get better. It would never build on what it learned. You would just have endless noise with no memory, no history. Okay, so now let's zoom all the way out. Let's take this Courier idea and think about it on a cosmic scale. Because what we're talking about here is that we have accidentally built, in silicon, a synthetic version of panspermia. You know, the theory that life spreads across the universe on things like asteroids. And when you put them side by side, the parallel is just wow. Cosmic panspermia talks about spores seeding new planets. Backpropagation has credit seeding new network setups. Panspermia has meteorites carrying the chemical building blocks of life. The AI has gradients carrying corrections. It is the exact same job, transmitting structure that works, just in a wildly different environment. And to make all this work, the system even has its own little logistics department. You've got the attention mechanism, that's the route planner. It looks at all the incoming information and decides, okay, this part is important, let's focus here. Then you have gradient descent, that's the road construction crew. It takes the messages from the couriers and actually does the work, paving and widening the pathways that led to good answers, making them stronger for next time. So all of this, the couriers, the selection pressures, this whole system of transmission, it all leads to a really deep, kind of philosophical conclusion about what meaning even is. Not just in an AI, but maybe for us too. I mean, just let that sink in for a second. Meaning is the subset of structure that can be transmitted. This is wild. It suggests that meaning isn't some magical ethereal thing. It's just the patterns and ideas that are tough enough, that are structured well enough to survive being passed along. Whether that's from me to you right now, or from one layer of a neural net to the next. So what this really means is that survival isn't just about being right one time. That's not enough. Real survival, the kind that leads to meaning, is about being teachable. A pattern has to be shareable. Its value has to be something that can be communicated to the rest of the system. Okay, so this is it. This is the whole idea in a nutshell. Complexity, anything interesting really, only happens when you have a system in place to preserve and spread structure. These systems, these couriers, are the conduits for information. In the universe, that happens across space and time. In an LLM, it happens across layers and training iterations. Without those conduits, all you get is random variation with no memory. Endless novelty, but no history. No learning. So, where does that leave us? After this huge, cosmic comparison between nature and AI, what's the final takeaway? It's this idea. The universe doesn't write poems, but it invents couriers, and couriers invent poems to explain why they arrived. Maybe the universe itself doesn't have a purpose or grand narrative, but it is incredibly good at creating systems that transmit things that work. And maybe, just maybe, all the meaning we create, all our art, our science, our stories, it's all just the beautiful poem that the survivors invent to make sense of their journey. The meaning isn't the point of the system. It's just the afterglow, the shadow cast by whatever was strong enough to survive the trip.